I am Mike Guthrie, Vice President of Engineering for Quadrant International. My work today is typically larger projects. Work with some customer projects that take some time, quite a bit of involved ones in medical. And in recycling, I've done a great deal of research on those processes, and there's so many of those going on that consumes quite a bit of time in itself. Consumer electronics has driven the technology just hugely, especially in making small magnets, micromagnets. Get them down into measure microns as opposed to millimeters. For those, make a lot of them and have to do a lot of research on coatings to get those down where we want them. Electronics to get bigger magnets, the generators, renewable energy to make permanent magnets powerful enough to stay magnetized and produce enough field-generated electricity. For the wind generators, tidal generators, we need high induction. We need actually a lot of material, which is becoming problematic. But it has pushed us on going large, going small, and going high energy, and working a lot on reducing or abating the susceptibility to corrosion. Lots of challenges. And recycling is in its infancy. There are a number of people, a number of entities all around the world that are working on recycling. The vast majority, almost all of them, will recycle down to a mish metal. So it's a mixture of all these rare earth materials that we have. And it will not pull out the neodymium from the samarium. And we need to do that to make the magnets that we're making. We can make mish metals, but it's kind of like a waste of some of the rare earths that will make a very strong magnet. It'll reduce it significantly. These techniques are getting the magnet down to the specific rare earth. The major challenge right now, as I see it, is finding a dedicated resource. We can recycle magnets, and you get a truckload of hard disk drives. We can get a wind generator and take it apart, doing that now, recycle those materials. But you need a continuous line of those, an influx, to be able to set up a line and do these things. And then you need to segregate all of the tiny magnets in consumer electronics devices and hard disk drives from the copper and the steels and the materials that you have, and get those magnetized materials out of a wind generator. Normal people can't pull those suckers out. So there are special techniques on being able to do that, but the process is in its infancy. There are a few processes, and it depends what you're going to use with the material that's extracted from the recycling. Depends where you put it back in the process. Often you can take these magnet materials out and then throw them back into companies that make the raw materials. Actually, those work very well. A lot of people are doing that. And then have them give you the pure metals out that you want to use and make your magnet. Put them back. If you can get those rare earths out, then you can just make your magnets from that, and they work well. Go into the process, and then you're going to make the magnets the same way that you've made them in the past. Recycled magnets look just like, taste just like a real magnet. It is necessary for the circular economy. You're going to have it. Our rare supplies are running low worldwide, and when you can make a magnet, give it to a company, have them make their product. This is the hard part. Get their end user to turn that worn out piece back in and have it recycled. Then you can bring it back, recycle the magnets, recycle the device, and melt it down, and recycle it, and put it back in, sell it to their customer. So recycling is going to help just tremendously on the supply. Global supply of rare earths that is significantly depleted now.